go. There was still,
2002.
what's that?
It said it happened in 2002, October 2002.
So that is post 9/11 then, right? Because that was 2001.
Yep.
Yeah.
Okay, so 2011 happens, right? Massive impact on now the way we look at security, who can board planes, what can they have on their
2001?
plane. I don't want to miss, what is somebody saying?
Sorry, you just said 2011?
No, I think 2001. Isn't that when 9/11 was?
Mm-hmm.
Yes.
Yeah. I
2000.
was just confused. I thought you said 2011.
No, 9/11, 2001. Anyway, so a huge impact, right? And after that, we are trying to minimize risk as much as possible, right? We're like, what can we do to minimize risk? So we will do anything and everything to make sure there's not a whole lot of risk. Now, how many people had put bombs in their shoes? What was the correlation between attacks on the United States and wearing shoes at TSA? That correlation was very, 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 very small. I think it happened one time. So that is what would be considered a small effect size, because the relationship between an attack on an airplane and wearing shoes during security screening, that there's only one event that could have been prevented, maybe three, let's say three total of people who tried. But that's very, very little considering the thousands and millions that fly every day, okay? But that is still something that we do to prevent that from happening. And the reason why is it's not that big of a deal to take off your shoes. And if it means you're not going to have a bomb in your shoes, they've decided that's worth it. Okay. So that would be an example of a small effect size, because the relationship between like wearing shoes during security and then something happening to an airplane, that is a low relationship, a low correlation. Does that make sense?
Yes.
Okay, so larger effect size shows stronger associations between variables, but at times even small effect size relationships are still important and doing the behavior makes sense, like aspirin.
So would you say that, like, I mean, more of like the TSA, it's kind of like a preventative action, kind of like preemptively, where it's like, it would be too difficult to try to get around it. So it's just like, please don't try.
Well, yeah, and I think it's to a certain degree, it's like, well, it's controlling the uncontrollable, right? So we don't know the potential risks, but we do know the ones that have succeeded or have gone through. So if we control for that, then we at least are safer from that. There's always going to be potential risks that we don't know about, but if we at least control for what we do know, then we feel safer. So there's kind of the psychology of safety with that too.
No, awesome. Thank you.
Yeah, no problem. All right, so how do we determine if a correlation is statistically significant? So that is doing a bunch of stats to determine if the relationship is in fact due to an association between the variables and not random chance, okay? So a statistically significant result means exactly that the result that was shown, right? And how do we know statistically significant? What's usually shown for that?
A positive correlation?
No, but how do we know it's statistically significant? Usually they'll do a P is smaller than 0.05, right?
Oh.
Have you guys seen that in journal articles?
Yes. Thank you for
Yeah.
clarifying that, because that has always eluded me when I'm reading all these articles. Like, why is that a thing?
Yes.
Okay.
So in journal articles, when they write that, that is the authors of the study telling the reader, hey, I'm making this claim about the association of these two variables, and I am telling you it is statistically significant, which means the probability that these results showed a relationship that are due to chance, right? That's just randomness. It is less than 0.05%. Okay. So we are this is looking at, like, again, remember confidence intervals back in statistics?
Yep.
And you would say we are 95% confident. I think I misspoke here, less than 0.05. So, or 5%, not 0.05%. So that means I am feeling very confident that the relationship between these two variables is in fact because they are related and not haphazardly due to chance. Okay. So let's look at a couple of tables so we can make sense of it. So this is the correlation with well-being, and you can see here several interaction variables. So being alone, this is kind of a funky study, but being alone is negatively correlated with levels of happiness. I would say this is probably going to be somehow in groups that are actually extroverted, because introverted probably would be fine with that. The first thing you should notice is that there's an asterisk next to it. So when you see that in tables, the first thing you need to do is go down to where's the asterisk and what does it tell you?
So our P is less than or equal to 0.05.
Yes. And if you see one that has 2 asterisks, it's right here. That means it's less than 0.01. So we've reduced even more the likelihood that the results were due to error or chance. Okay. So these are correlational scores. Okay. Correlational values that are R values. So remember, what do correlational values range between?
Correlational values range between -1 and 1.
Yes. And so here we have negative 0.27 and negative 0.35. They're not massive, right? According to our chart earlier, they wouldn't even be in the strong effect size. They wouldn't even be like a strong relationship, but they are still statistically significant, okay? The way that you can have a value like that still be statistically significant, even though it's a little smaller, is if you have a very large participant pool. So that's another way that you can kind of manipulate that. So, okay. So that is how you would understand what is statistically significant when you're reading a paper. Now, is it possible that an outlier is affecting the association? Okay, so look at these two right here. These data points are all the same. The only difference is this dude over here. But see the impact on the correlational scores. That is pretty significant. Now, what do we do if you get an outlier like that in your results? What should you do?
Now, can you simply just disclaim it in regards of saying there was an outlier that we took out because it didn't show that it followed the trend?
Well, I don't think that, no, I mean, I'm thinking about like the toothpaste example, like 1 in 5 dentists recommend Sensodyne, but I don't think you can necessarily toss out one dentist that says it sucks compared to the other one.
That's true, Elizabeth. Yeah, you probably don't want to do that. I think so you need to be careful, I think is the bottom line, because you're right. We don't want to just discredit information and toss it out. But in this case, when you have a very large number of data points that are all clumped together and you just have the one outlier, and the outlier is having a significant impact on your statistical result and your analysis, you need to say something about that. You need to address it one way or the other, because this here is faulty information, right? Like this 0.37 does not represent the majority. It is in fact getting skewed by this one outlier. So you would need to have a discussion in your paper as to why you would want to kick it out. And you would want to figure out if there's something unique about this participant in your study that doesn't fit what you were looking for anyway. So regardless of what you do, whether you kick it out or not, it needs to be discussed because the disparity in score is very significant. I mean, same here. This guy right here is changing the correlation from 0.15, which is very mild, to 0.49, which is very significant.
When would it ever be appropriate to omit a variable or a participant that is skewing your data?
It would be very frequently permissible. You just need to discuss it. So if let's say you had 20 participant and you had 4 outliers,
Yeah.
then I go, well, now you're taking away a significant part, like 20% of your data set, you're considering an outlier. I would say that's not a good idea.
So I
There's,
get, sorry to interrupt. Go ahead.
I was gonna say, there's probably something going on. If those 4 have an outlier kind of response, there may be something going on
Where the
within that.
question was phrased
subgroup.
wrong or something.
I didn't hear that. What?
So there might be something going on, like you look back and it's like, I phrased this question wrong. And some participants are thinking that it means this, and that's why they're skewing my data.
Possibly. That would be more in regards to reliability and validity. And that would tell me there should be a greater percentage than almost like a 50% usually that will show that be like way off on the other end if there's something about the writing. But you're right, that is definitely something you need to look into with outliers. Is there any issues of reliability and validity?
So like if we get our data back
Mhm.
on attitudes towards taking class in person or online,
Mhm.
and we get mostly people that say I love online, then we get the one person that says I absolutely hate being online.
Yep.
We can omit them.
Well, again, if you have quantitative data and they took an entire survey, right?
Yeah.
There should be multiple data points. Are they just really off into middle of nowhere compared to everybody else? If so, then I would want to know more about that person. I would want to get more information to fully grasp what it is. And you would discuss that. And then you could say something like, we had an outlier who absolutely hated online classes, and here's their
Yeah.
scores. And in fact, and you're not naming them, obviously it's all anonymous,
Right.
but you could even say their resistance to online learning was such that if we include them in our data, here's the result we would get as to the strength of the association. And if we take them out, here's where it is. So we go from significant results to non-significant. Like you would have to explain it away.
Okay.
Does that make sense?
Yeah, thank you.
Yeah. And I would help you guys out with that. Okay. All right. So restriction of range, we talked about this a little bit earlier. So you could see if you are looking only at a subset of the possible ranges of score, you may get a different result as to your correlation than if you look at the whole breadth of it, okay? So notice here, this is college grade GPA correlated with SAT scores. But what do you notice about this graph?
Well, they don't have anything that's like really like the what do you call them? Like the tally marks that say like, oh yeah, like this is the
That's
numbers in
true.
between.
The graph is not very well laid out. Sure.
Yeah.
Is it possible to get an SAT score below 1200?
Yes.
So
That should have been a good, better one.
so if you're looking at this, what conclusions may you draw from this sample size?
That they only took the upper end of the people who like actually did well on the SATs.
Right. That maybe this this school only had students who got 1200 and higher on the SATs, right? There's no scores below that. So what would make me think that they actually included them? Now let's look what happens here. Oh, they actually did. They had several that were between, this is a slightly different one, but this is the new version, I think, of the SAT, which goes up to 2400. If you stop at 1800, you could see that the correlation is 0.33, right? It'd be like a line of best fit, kind of like this. If you look at the entire range, you might be looking at something much stronger. Now, this particular graph feels confusing to me because it seems more flat to me when I look at it. But the correlation is actually stronger because these dots are closer down to the bottom, right? They kind of end here, was over here, you've got several higher ones and you've got several that are in the low range, even if you go high. Do you guys see that? So it's not quite as strong of an effect size. There's more variability. So again, you want to make sure that you are not restricting range so that you can look at the true correlation. All right, this is a curvilinear relationship. This is what I was talking about earlier, right? Use of the healthcare system, slightly different, and then ages and years. So you could see again, the correlation coefficient would actually be 0.01 if you just tested it, which anybody would go, well, that's negative, right? That's a non-relationship, not negative. It's a non-relationship. But there is actually, as you can see, it's really clumped together. There is a very significant relationship. It's just curvilinear rather than being linear. Okay. So now how do we apply the 3 causal criteria when we look at correlation? Okay. Again, statistics it always wants to know, did this cause that, right? Did the presence of COVID and you experiencing stress cause weight gain, right? What's hard about saying things like cause? It's not a hard word, obviously, but like what is the implication?
There could be many variables that would contribute to weight gain, not necessarily only COVID.
100% spot on there, Elizabeth. So absolutely. So when we use the word correlation, we are not saying causation. Correlation is association and relationship. Causation is this led to that, right? The only way that we can do that would be in experimental studies, for instance. You had this symptom, I introduced this drug, now you don't have these symptoms. And nothing changed, right? The drug was the only variable that was manipulated. Ergo, because of temporal precedence, this happened, then we saw a change in symptoms. We can say with a certain amount of certainty that that is a causal relationship, okay? So in order to evaluate causal criteria, we need to look at covariance, meaning as one variable varies, does the other variable similarly vary as well? Is there temporal precedence, meaning that one thing happened first, which then led to the other? And is there strong internal validity, meaning there's no other third variable that could have played a role in explaining a change in a variable? Whoops, looks like somebody got kicked out. All right, so those are the 3 causal criteria we need to look at. So let's divide them one by one. So covariance, again, is do the results show that variables are correlated and they co-vary together? Temporal precedence, again, does it show like a linear directionality? This then happened to that, or this, to that, right? Depending on which one. If you can't tell which came first, we cannot infer causation. This is back to the chicken or the egg, right? What happened first, right? Did we talk about this in this class already, like praise and narcissism?
I don't think so.
No.
Okay, so back in the 80s, psychological studies started shifting because parents, researchers, right, were trying to figure out how can we make sure that children have a strong sense of self-confidence and self-esteem, right? Self-esteem became kind of a coined term. And then there was a change in how things were done. So this was like late 80s, early 90s. And we're like, we need to build self-esteem. Children should feel good about themselves. We need to praise them. And then you had another faction of social scientists who said, wow, now we've got a bunch of kids that are getting trophies for no reason, right? Like you guys probably have heard these kind of statements, right? Everybody's a winner. That's such baloney. No one's a winner, right? Well, some people are a winner. And you know what I mean? And then all the way to the other spectrum, which is you keep praising, we are really educating and growing an entire society of little narcissists who think they are the best in the world. And again, you guys have likely heard that in popular culture and media, right? That certain generations are being pegged as like, wow, they think the world should come to them and that they're so deserving and they don't have to do any work, that it should just come, because they're so special and wonderful. I'm not coming out of left field, right? You guys have heard stuff like that?
All the time.
all the time. So the study was done to show, okay, as a child, how much praise are you giving? So it's a longitudinal study. How much praise are you giving your child? And now let's measure levels of narcissism. Okay. So we can then do a very direct temporal precedence test. How much praise did you give at time A? And what was their score on the narcissistic scale at time B? Right? Did the level of praise you give impact their score on narcissism at time B? And so on and so forth. You can keep testing it out, right? That would be a way to look at causation because you have temporal precedence. Now, what might be a pitfall with that study? To just look at narcissistic traits as they relate to how much praise a parent is giving.
Because there are so many more, just like as I think Elizabeth said, there's just so many other factors that could be it.
Right.
'Cause,
What
like,
might
it's
be
not-
another factor?
I mean, class or like in school, did the kid get picked first for dodgeball, and then after that, was he just like inflated and like, oh, I'm so good?
Right.
Did that just play into it? And like, there's just so
Right.
many other things like,
Yeah.
eh.
So I'm seeing people saying nature, nurture, yes, genetics, totally. Those all play a role, right? Like our mom and dad also kind of full of themselves. There's a greater likelihood then the kid's going to be also. What about pervasive personality trait? That's just how that person is, right? So there's a lot of outside factors that are not solely measured just by how much praise did you give to your kid? Oh, 4 times today? Oh, 7 times? That's not necessarily a direct causation link. Anyway, so that's to give you an idea of temporal precedence. Internal validity, that's again looking at a third variable that is having an impact. So yeah, A and B right here, they have a relationship, but it's really C that is pulling it all together. Okay. So the C is associated with both of them, and that is where the strength of the relationship lies. Okay, let's give it a couple examples of that. Okay, so this is how the a third variable such as education could have an impact. Okay, so let's see here. We're looking at the percentage of substantive or deep talk and level of well-being. Again, this is a Z score. And then we're looking on, I'm trying to see, I noted, okay, the more educated participants are represented by green dots and less educated are by blue dots. So what do you notice?
That the blue dots are more towards the bottom in both of the graphs.
Right. So if you're asking yourself, is there a relationship, a statistically significant correlation between the amount of substantive conversations you're having and on a well-being scale score? Maybe there is a relationship there, but the much stronger relationship seems to be levels of education. That is really what's pulling the scores, okay? So if education is not causing an internal validity problem, you can see they're far more scattered here, okay? They're not completely divided like they were over here. All right, let's look at another example. Oh, this is external validity. So how well does our results represent the population at large that we were trying to mirror, right? Because we used a sample. No one can use a full population. That's just not realistic. So how well did our sample mirror our population? Or in other words, how generalizable is our study? Okay. We see here the percent amount of time that's spent multitasking and then your score on your ability to multitask. And then that's divided by the age of the participant. So it's old and young. So older adults are represented by 0 or O's, I should say, and younger adults or college students are represented by Y. What do we notice?
Well, we can definitely see that more younger people will spend a lot of time multitasking.
Yes. Are they better at it?
No. Yes.
Yeah, I think
Yeah.
they are.
Yeah.
Right? The older adults are really in like no more than 60% on their accuracy score, right? Whereas you could see it goes much higher for younger individuals. Okay. So again, you can't ignore age as having an impact on these scores because that is a significant impact. Okay. So we talked about external, how generalizable is it? Do we have, oh my gosh, there's a spider crawling down right in front of me. Catch it. How are there spiders already, you guys?
Charlotte.
Sorry, it's crawling all over my desk. Ah! I'm so glad this is being recorded. Blech. Okay, we're good. I got it. Almost fell in my tea. Keep breathing. All right.
Drink some more tea.
Yeah, more tea, more tea. All right, moderator. Moderating variables are when the association between two variables changes depending on the level of another variable. Okay, so there's this external variable. If you change that, then the strength of the relationship between these two other variables is also going to change. So one of the studies that's described in your textbook is the relationship between team success and game attendance. The idea if a home team is playing, which again, like how well does that work with COVID? Not so much. Can there be fans at any professional level of sports now?
Football used to have like 30% attendance.
Yeah, and I
Oh.
think like celebrities can get in as
What?
long as they're like COVID tested and stuff.
That's
That
rude.
doesn't seem right.
They opened like spectators for some of the like collegiate games too.
Okay. Well, I'm out of the loop because I was going to say there hasn't been really any spectators. But anyway, so what would you say is the relationship between team success if they're playing at home and there's high level of attendees?
Low this year.
Right. Any other year, though.
Yet high. The only reason why I have a fun example. I went to a Notre Dame game a while back against Georgia, and there were more Georgia fans, and Notre Dame like they couldn't like play. Sure,
Really?
like Georgia was good, but they were just like the fans were so loud for the other team that it was the first time it was like, holy cow, home field advantage, like it's a thing.
Wait, but was the game in Georgia?
No, it was in South Bend, Notre Dame.
Oh,
Yeah,
but there are
and it
more
was-
Georgia fans. Huh.
Yeah, and it was because like the Falcons were playing like Detroit or like the Bears, so like all the fans from Georgia came up.
Ah, there you go.
Yeah.
But usually that's how it goes, right? Like a team wants to play at home because they want to feed off of the crowd, get excited, and they feel like there's a greater likelihood that they'll perform better, greater chance of winning the game. Now, you throw in there, what is the rate of residential mobility? So, is there a correlation between attendance that would be more of a fair weather fan? Like people will go if, if things are okay, if the weather's nice, if it's not too expensive, I'll go, right? So that would be higher level of residential mobility. Like it's easier to go in Arizona, right? It's just easy to make a last minute decision than Pittsburgh, where you are only going to get the diehard fans that are going to sit out there like freezing their tushies out watching, I don't know, football. Sports is really my weakness, but so what's the relationship there between the two? But now there's kind of a moderating variable, which as we just talked, it's that mobility, right? How easy is it for them to play? So this is the percentage of wins. I feel like I can't even see my cursor here. Percentage of wins versus attendance. And you could see here, Arizona kind of has a positive relationship. They have a high level or moderate level of residential mobility. And then each dot is, again, a Major League Baseball season and how they played. This one, you can see kind of a negative relationship, percentage of wins and attendance, because it has low residential mobility. So that is the moderating effect that is impacting the relationship between the two variables, which is attendance and percentage of wins. Okay.
Now, sorry to interrupt, but would a third factor be like how well the team is doing that season?
Absolutely. Right. So that would be something else that you could look at for sure, like
Oh.
track record of the team. Yeah, because then maybe you have fans that are going, but they're like, boo, like they're not being friendly.
I do know that like in baseball, like they do like groupings of like 7 games or 5 games because it's like, hey, like we're near you. Let's just play a lot.
Yeah, I think usually, is it 3?
Yeah, I'm not a baseball guy.
I
But
don't know
that
either.
makes more sense. 3 sounds good.
Well, no, we need somebody to verify this. I don't feel confident. Anybody who's a sports person? Oh, wow. We're like making this.
I don't think a lot of people like baseball anymore. At least like
If there's any softball or baseball players, sorry for knocking your sport team here.
sorry.
I think is somebody writing it on the chat? No. I do think they play way more games than in football or basketball. And I
Yeah,
think
they
that it's
play
one
like
of the reasons,
100 games. Yeah.
like over 100 for sure. Yeah. Okay. All right, here's another moderating variable. This is gender, as it moderates the relationship between extroversion and group conversation. Okay.
Oh, sorry, just to interrupt you. I looked it up. It is 3.
Oh, it's
Teams
3.
normally play series of 3, occasionally 4 games during the regular season.
Okay, there we go. Learn
And then
something.
isn't it? I think it's 7 for like the World Series or whatever it's called.
Oh, during playoffs.
Yeah.
Makes sense. Okay. So you can see here, this is the association between extroversion and the percentage of group conversation. So if they're extroverted, how much are they talking about or talking in big groups? And you can see for males, it's 0.07. For females, it's 0.49. And the 0.49 here is a statistically significant result. Okay. But if we look at this, the relationship between extroversion and group conversation is dependent on gender. There is a split there between males and females. So it's not that extroversion alone, isn't related. I'm saying that wrong. Extroversion isn't related to having a higher percentage of group conversation in men. Okay. That is not a correlation, but it is in women. Okay. So if you just look at those two variables together outside of gender and you clump them all together, you might get a medium or moderate relationship. But as soon as you split up gender, you recognize, oh, that's really gendered, right? So it's really women that holds true for. Okay. And this is when gender does not moderate the relationship between extroversion and being alone. So when it's split up, then you can see here, both cannot, they end up being both significant. This is weekend and weekday status. What is that of? I forget what that was about. Oh, whether relationships and discussions changed or differed between conversations during the weekday versus conversations during the weekend. Which some people might go, I don't have time to have deep conversations during the week. I'm busy and working. This shows that they're both statistically significant. So it showed that the day of the week did not moderate the relationship between deep talk and well-being. So the relationship between the two remained the same regardless of when they talked. So the day of the week was not an effective moderator. Uh-oh, did I lose you guys?
What? No.
Okay. Okay, here you are. My whole screen went black. That was the last slide, so that kind of worked out for it to crap out. All right, does that make sense? Bivariate correlation.
Yeah.
Okay, next week we're going to be talking about multivariate correlation. And again, we are not having lecture until 2:45 because I'm meeting with each of you in your groups starting at 1. Look at the schedule. It's actually noted on there on Course Connect. What is due by midnight today?
Reference.
References.
References are due, right? You all need to connect with your groups between now and next week to figure out surveys so that you come prepared for our meeting on Wednesday. And then you need to start working on your literature review so that that can get all completed because it is due next week. Again, the goal is to have 4 to 6 pages written of content that is excluding your title page. And you want to make sure that you are integrating the research articles you found. Please follow the example that I attached on Course Connect and also that literature review how-to website that provide a lot of good tips and pointers. All
Thank you
right.
so much.
Thank
Any
you.
questions?
I think I'm all good.
Okay. All right, then I will see you all next week.
Thank
See ya.
you.
All right, bye guys.
Bye.